So dear students, welcome to my YouTube channel PCM Academy, and today I am going to discuss with you the special theory of relativity, and this is actually the revision of special theory of relativity. I will discuss with you only the formulas involving special theory of relativity that are very useful for problem solving purpose for your competitive exam like ID, JAM, jest, TF, etc. And this course is specially designed for the students of JAM 2021. Okay, JAM 2021, and this is actually the crash course, you can say. I will discuss with you the formulas and the problems. So mainly this is actually the revision course with some solved examples that you can understand how to apply the formulas, which is very important for these exams. Okay, so first we need to know about the formulas which are involving in this theory, that is special theory of relativity. And the very first one that comes in our mind is about special theory of relativity is very famous, that is Lorentz transformation. Okay, so let me give you the formula involving Lorentz transformation. Lorentz transformation. Okay, this is nothing but the coordinate transformation between two inertial frame of reference. So let us consider this is a frame. This is a frame S. Okay, this is a frame S. This is also, of course, an inertial frame of reference S. And there is another frame of reference, that is S dash, which is moving with constant velocity v with respect to S frame. So this S and S dash both are actually inertial frame of reference. This is origin O. Okay, and let me suppose there is a point P. P has the coordinate x, y, z, t with respect to S, and the same point have the coordinate x dash, y dash, z dash, t dash with respect to S dash frame. Now the Lorentz transformation says how this x and x dash, y dash, z dash and t dash are related. We can prove it, but we don't need to prove. We have to remember the formulas to applying the problems only. Okay, so let me give you the formula directly. What is the transformation relation between this x dash, y dash, z dash and t dash? So if we want to derive, you can derive it, but here the x dash is related to x as like this. X dash is equal to x minus vt upon root 1 minus v square upon c square, and y dash is equal to y, z dash is equal to z, and t dash is equal to t minus vx upon c square divided by root 1 minus v square upon c square. These are the Lorentz transformation relation between x dash and x, y dash, y, z dash, z, and t dash t. And you can find the inverse transformation relation by putting minus v instead of v, and we will get x in terms of x dash. Okay, and in that case the relations will be x is equal to x dash plus vt dash upon root 1 minus v square upon c square, y is equal to y dash, z is equal to z dash, and t is equal to t dash minus vx dash upon c square. Sorry, t is equal to t dash plus vx dash upon c square divided by root 1 minus v square upon c square. So if these are the Lorentz transformation equation, then they are the inverse Lorentz transformation equation. Okay, so you have to remember this formula. Okay, so now let me move to the next topic, that is the velocity transformation. Okay, so let me understand about now velocity transformation, which are also based on this Lorentz transformation equation. So velocity transformation. Again we have the same situation, that is one is S frame, another is S dash frame, and this S dash frame is moving with velocity v with respect to S frame, and there is a point P. And let me suppose that the velocity component of this point P is ux, uy, uz with respect to S frame, and this point P has the velocity component ux dash, uy dash, uz dash with respect to S dash frame. Now again we have to remember how ux dash, uy uz dash, and uy u dash and uz dash are related. Okay, so if we know this ux uy uz with respect to S frame, then we can write ux dash uy dash with uz dash in terms of ux uy uz and v. But v is the velocity of the S dash frame with respect to S, and these are related like this. This ux dash is equal to ux minus v divided by 1 minus ux into v upon c square. Similarly, you can find uy dash is equal to uy root 1 minus v square upon c square divided by 1 minus ux v upon c square, and uz dash is equal to similarly uz root 1 minus v square upon c square divided by 1 minus ux v upon c square. And you can see the results that the denominator is same in each case, and the component of velocity is that in which direction the frame is moving. So here the frame is moving along x direction, so here the component is of velocity is ux. But in ux dash the formula is different, that is ux minus v. This is the relative velocity, and actually the velocity, the frame is moving along x axis, so here is ux minus v. And in other cases there is a different kind of situation, that is uy is equal to root over 1 minus v square upon c square, and uz root over 1 minus v square upon c square. So these are the velocity transformation relation between S and S dash frame. Again you can get the inverse relation, that is you can get ux as ux dash plus v upon ux dash plus v divided by 1 plus ux v upon c square, uy is equal to uy dash plus v 1 plus uy v upon c square, and uz is equal to uz dash plus v dash away, okay, ux dash plus ux dash plus v divided by 1 plus ux dash v upon c square. So when you want to do the inverse transformation from the transformation relation, we will just put v as minus v, all will be same, okay, and you will have to put dashed in the right side, because we want to get ux in terms of ux dash, and here we want to get ux dash in terms of ux. So in transformation relation always we want to get the variable involving with the S dash frame, okay, in terms of S frame, and in inverse we want to find the variable involving S frame in terms of S dash frame. So this is our case. So sometimes we will use this, sometimes we will use this. We will use the formula according to the problems. So the application of this formula is very important. How you apply this formula, which formula is suited for which problems, this is very important. So you have to practice lots of problems to understand this thing, okay. So this is the velocity transformation formula. Next I like to discuss about the length contraction as well as time dilation, okay. So these are also very important for your exam purpose. So the next topics I want to discuss about the length contraction, okay. So let me understand about length contraction. Okay, so here again we have to consider two frame. One is S frame and another is S frame. And again this S frame is moving with velocity v with respect to S frame. And here let me suppose that there is a rod of length L. There is a rod of length. Suppose there is a rod. Okay. And the rod is in S frame. In S frame. Now, if we measure the length of this rod from this S frame, and let me suppose that the length is N0. So, this N0 is called proper length. If we measure the coordinate, this is x2 dash and this is x1 dash from the frame S dash. When the rod is in S dash frame, and the person sitting in S dash frame measured the coordinate x1 dash and x2 dash, that is x2 dash minus x1 dash is equal to N0. This is actually the proper length of the rod. Proper length of the rod. Proper length is that length which is measured by the observer with the frame where observer with the same frame where the rod is present. So observer and the rod or the object are in the same frame. When they are in the same frame, then the measured length is called proper length. Or you can say it that the proper length is that length which is measured by the observer with the rest frame of that object. Here S dash frame is the rest frame of the object. Okay, so this is the proper length. Now, if another one which is sitting in the frame S, and if he measured this coordinate as x1 and x2, that is x2 minus x1, then he will measure L, that is observed length. Observed length. Observed length. This is not proper length. Proper length is that length which is measured by the observer sitting on that frame. But if you are sitting in another frame and you will measure the length, then you will not get the actual length or the proper length. And this L and N0 are related by this equation, that is L is equal to N0 root 1 minus b square upon c square. And you can see from this equation that as v by c is less than 1, so this term is less than 1. So of course L is less than N0. As this is less than 1, this term is less than 1, so L will obviously less than N0. So you can say the length is, the observed length, the measured length is less than the actual length. So you can say the length is contracted. So you can say the length contraction. The phenomena we can say length contraction. And this formula is very useful. But you have to understand what is L, what is N0, what is V. V is the velocity of S dash frame with respect to S frame. And N0 is actually the proper length. And L is the observed length. And proper length is which length? When the observer and the object are in the same frame. Then he measured the coordinates or the length of the rod, and that length is actually the proper length. So you have to understand this thing. What is proper length? What is observed length? Observed length is measured from another frame, another inertial frame. But proper length is measured from the same frame where the object is present, or you can say the rest frame of this object. This is the actual proper sentence, the rest frame of this object. Okay, so this is the length contraction. Similarly, we can find the time dilation. Okay, we can measure time dilation. This is something slightly different from this formula. That is, the situation is same. We have two frame of reference. One is S frame and another is S dash frame. Two frame are same. That is time dilation. The frame are same. S and S dash is moving with velocity v with respect to S. Now we have a clock over here. Suppose we have a clock over here. We have a clock in frame is dash, and we have measured any time interval in S dash frame. Any time interval in S dash frame. That is, you can say T2 dash minus T1 dash. This is a time interval. Any suppose a blasting is occurring over here and its time interval is T2 minus T1. So any phenomena which is occurring in the frame is dash, and the time interval for that phenomena is T2 dash minus T1 dash. Or you can say simply that there is a clock and the time interval that is T2 minus T1 dash. This is actually, you can say, tau naught, and this is actually the proper time interval, you can say, or the proper time. This is actually the proper time. So proper time is again that time interval which is measured by the rest frame of the clock. From the rest frame of the clock, or the observer and the clock, when the observer and the clock are in same frame, then that time interval is treated as the proper time interval. And if there is an observer in S frame and he will observe the phenomena and measure the time interval, that is T2 minus T1, that will be tau, and that is observed time. That is observed time. And here this it can be seen that this observed time T will be greater than T0 or tau 0. And these tau 0 and tau are related like this. Tau is equal to tau 0 upon root 1 minus b square upon c square. And you know that this is less than 1. So as this is less than 1, so tau is obviously greater than tau naught. So the observed time is more than the actual time, so you can say the time is dilated, and that's why the phenomenon is called time dilation. Okay, but again you have to understand what is the proper time and what is the observed time. Only understanding that you can apply the formula in problem properly. Okay, so these are very two important formula. One is the length contraction and another is the time dilation. But the application of these two formula is very interesting, and you have to always care about all these things. The frame of reference, the velocity with respect to other, and which is the S dash frame, which is S frame, which is proper time, which is observed time, is all very important. Okay, so now let me move to the next topics, that is the variation of mass with velocity. This is also a very important topic. Okay, variation of mass with velocity. Okay, in Newtonian mechanics we have seen that mass is constant, but when the velocity is comparable to the velocity of light, that is v is equal to alpha c, where of course alpha is less than 1, and in that case you know that this mass is variable. The mass of particle is varies with velocity. The mass of the particle will be function of v, and this is related by this equation: m is equal to m naught divided by root 1 minus b square upon c square. Okay, m naught upon root 1 minus b square upon c square, where m naught is equal to rest mass of the particle, rest mass, and m is the moving mass. Okay, this m is directly depend on v. If v is varying, then m will also be varying. But m naught is constant. This is constant for each and every particle. There is different rest mass for each and every particle. And in that respect, if you want to write the Newton's equation, that is F is equal to dp upon dt, then you have to put p as mv, but this m is replaced by this relativistic equation, that is d dt of m naught v upon root 1 minus b square upon c square. So you will get the fourth equation from here. Now what is the relativistic total energy? This is also very important. What is the relativistic total energy? relativistic total energy of the system. Relativistic total energy of the system. Total energy of the system. Relativistic total energy of the system. Okay. So what is the relativistic total energy? According to Einstein, E is equal to mc square. That's it. But if we want to get the other formula also in terms of P, that is P is equal to mv, we put P is equal to mv, where m is always the moving mass here also, not the rest mass. So in that case you will get, and if you put also m is equal to m naught upon root 1 minus v square upon c square, and if you involve all this thing you will get a very famous equation, that is the energy equation of relativistic particle, that is E square is equal to p square c square plus m naught square c to the power 4. It is a very famous equation. This is the relativistic total energy. This is same. And this can also be written as relativistic energy is nothing but the rest mass energy plus the kinetic energy of the particle. Rest mass energy plus kinetic energy. This is the total energy is equal to mc square. This mc square is nothing but it can be split into two parts. One is the rest mass energy and another is for the moving, that is kinetic energy. So if we put E is equal to mc square, then we will get another equation, that is mc square is equal to m naught c square plus t, and we will get t as m minus m naught into c square. So this is another famous equation of kinetic energy. Kinetic energy of relativistic particle. So this is the total energy of relativistic particle. This is also the total energy of relativistic particle. You can put in this form also, that E is equal to root p square c square plus m naught square c to the power 4, and this is the kinetic energy of the system. Okay. So now let move to another thing, that is the transformation of energy and momentum. Transformation of energy and momentum. Okay. Transformation of energy and momentum. Transformation of energy and momentum. Okay. So let us suppose that there is S frame, okay, and that is in S frame the momentum is, let me take it as P, or you can say the X component of momentum, you can say, or you can say it is P. Okay, P is the momentum and E is the energy. Okay, and it is this frame, that is P dash and E dash. Now the transformation relation X component of momentum Px is nothing but, if we talk about the inverse relation, then Px is nothing but Px dash plus Ve dash upon c square divided by root 1 minus b square upon c square. Similarly, Py is equal to Py dash and Pz is equal to Pz dash. And if you want to get that transformation relation, then you have to put Vh minus V. Okay, so you can get it like this, that is Px dash is equal to Px minus Ve upon c square divided by root 1 minus b square upon c square. Similarly, we can get the energy relation, okay, energy transformation, that is E is equal to E dash plus Vpx dash upon root 1 minus b square upon c square, or you can write it as E dash is equal to E minus Vpx upon root 1 minus b square upon c square. Always remember, if you want to get the transformation relation from the actual relation, you have to put V instead of minus V. So you will get always the plus relation in inverse relation, and in actual relation you will get the negative or minus relation. Okay, so this is nothing but a transformation relation between momentum and energy. Now let me move to the next topic that is very important, that is the relativistic Doppler effect. Okay, so let me understand the last topics of this relativity, that is nothing but the relativistic Doppler effect. Relativistic Doppler effect. Okay. Again, let me take this is a frame where this is the source, rest frame of source, you can say rest frame of source. Okay, source of light of frequency nu naught. Okay, source of light of frequency nu naught is emerging like this at an angle theta naught, and in another frame which is moving with velocity v, and here let me suppose that the frequency of that light is nu and this is emerging with this axis at an angle theta. Now let me understand the relation between nu and nu naught. Okay, relation between nu and nu naught. So what is the relation between nu and nu naught is very important. Okay, so you have to remember this, you can prove it, but the remembering is also important for your problem. So you can prove that this nu is nothing but nu naught root 1 minus v square upon c square divided by 1 minus v upon c into cos theta. So this is the frequency when the frame is moving with velocity v, and this is the frequency and the source of light in the rest frame. So and the relation between nu and nu naught is like this. But you can see that if the observer is like this, the situation is like this. Here, if this is the situation that the light is moving in this direction, and here is the observer like this. This is the observer. Then here actually this theta, you can say this is the x-axis. So if the observer is here, you can say the observer is here. In that case, the light is moving at an angle theta with the observer. If in this direction there is the observer, then the angle this theta is between the observer and the direction of this light. Okay, propagation of this direction of this light in this direction. But if the light is moving in this direction, that in that case theta is equal to 0. In that case theta is equal to 0. Okay, if when theta is equal to 0, when the light is moving towards the observer, when theta is equal to 0, and the light is moving towards the observer, then what will be the case? Then in that case nu will be what? Nu naught root 1 minus v square upon c square divided by 1 minus v by c. 1 minus v by c. And that will be nu naught root 1 minus v by c divided by 1 plus v by c divided by 1 minus v by c. Okay, you can simplify it. But when theta is pi, okay, when theta is pi, what it means? It means that the light is moving away from this observer, that is in this direction. Okay, and in that case, there will be plus sign, as cos theta is equal to minus 1, so here will be plus sign. So nu will be in that case root over 1 minus v upon c divided by 1 plus v upon c. And you can see from this two formula that here this nu is greater than nu naught, because the light is towards the observer, moving towards the observer, and here nu is less than nu naught because it is away from the observer. And if theta is equal to pi by 2, that is in this direction, if light is moving in this direction, theta is equal to pi by 2, then cos 90 will be 0. Okay, and in that case, in that case, this term will be cancelled. So you will get only nu is equal to nu naught root 1 minus v square upon c square, and this is known as nothing but the transverse Doppler effect. Transverse Doppler effect. And these two cases are known as longitudinal Doppler effect. Okay, So you will get sometimes problems from these topics also, that is the Doppler effect. Okay, so these all are the theory part, and you can say the problem solving tools I have discussed throughout this class, and in the next class I will solve some problems based on these topics, including previous year questions. Okay, thank you.